Hey, this is Coach Latham, your SOL review coach, and today we're going to talk about all the properties that you need to know in Algebra 1, and of course we're going to do it in under 15 minutes. The first set of properties that you need to know are the identity properties. Now, an identity property is where you get the same answer as the question you started with. Don't know what really happened there. You're going to get the same answer as what you started with. So if you stick an A in when you start, you're going to get an A out for the answer. The identity property of addition means that anytime you add 0 to a number, you get that number for an answer. An example from algebra might be 2x plus 0, and of course that's going to be 2x. That is the identity property of addition. The identity property of multiplication works the same way. Anytime you have a number and you multiply it by 1, you get that number for the answer. An example in algebra would be negative 3x times 1 is equal to negative 3x. Again, the easy way to remember these is that an identity is where you get, as an answer, the number you started with. In addition, you do it by adding 0, and in multiplication, you do it by multiplying by 1. Kind of the same, but different, is this whole idea of an inverse property. Now, instead of trying to get the same answer that you started with, we're canceling out what you start with in terms of the answer. The inverse property of addition is when you add a number to its opposite, and that gets you to 0. So it kind of cancels it out. Like in math or in algebra, you might add 5x and negative 5x. That's going to give you 0. In arithmetic, it would be like 5 and negative 5. That gets you to 0. That is the inverse property of addition. The inverse property of multiplication works the same way. Except in multiplication, when you cancel something out, you don't end up with 0. You end up with 1. So it's typically multiplying by the reciprocal. A times 1 over A is going to give you 1. An example from algebra would be 5x times 1 over 5x is equal to 1. So going back to the previous slide, identities, your answer is what you started with. Inverses, your answer is canceling out what you started with. That's how you can know the difference between those two different sets of properties. The next ones we're going to talk about have to do with 0. The first one is called the multiplication property of 0. If you know a number, say A, and you multiply it by 0, you get 0 for an answer. This is where you know that you're multiplying by 0. Here's my comment on this property. I think we all already knew that. It's called the multiplication property of 0. Now, the 0 product property is a little bit different and much more important for us. You don't know what A or B are. There are two numbers that are getting multiplied together, and the answer is 0. Knowing that A and B multiply together to give you 0, you can figure out that either A is equal to 0 or B is equal to 0. This is going to be very, very important as you go through solving quadratic equations. So the 0 product is where you're given that two numbers multiply together to equal 0, so you know that one of them have to be 0. And the multiplication property of 0, you're multiplying a number times 0, and you figure out that the answer is 0. The commutative property. Well, really the only problem with the commutative property is that we sometimes get it confused with the associative property. So these two kind of go together just from the standpoint that they're the ones that usually get confused with each other. The way to keep them straight is that commutative starts with the letters CO for change order. That means that if you change the order of things that are being added together, you still get the same answer. In other words, A plus B is equal to B plus A. 2 plus 3 is equal to 3 plus 2. I think we all know that. And in algebra, negative 2 plus 5x would be equal to 5x plus negative 2. That's the commutative property of addition. The commutative property of multiplication works the same way. A times B is equal to B times A. 3 times 2 is equal to 2 times 3. both those answers are going to give you 6. In algebra, negative 2 times 5 is the same as 5 times negative 2. So when you think changing order in addition or multiplication, you think commutative because it starts with CO. Now, in the associative property, the numbers don't change order. They're in the same order. What moves is the grouping symbols. A plus B plus C, A, B, C, they're still in the same order, but the parentheses move from these two numbers to these two numbers. And you're still going to get the same answer when you regroup them in addition. An example in algebra would be 6x plus 2 in parentheses plus 3 is equal to 6x plus 2 plus 3 in parentheses. An example in arithmetic would be something like 3 plus 2 plus 1 is equal to 3 plus 2 plus 1. No matter how you add them up, you're going to get to 6. It works the same way in multiplication. The numbers are still in the same order, A, B, C, A, B, C. The only thing that changes is the grouping. And an example in algebra would be 2x times x is equal to 2 times xx, which would be 2x squared. So there is the associative properties of addition and multiplication. All right, these properties you can group together. The first one is the reflex. A is equal to A. Really? They got a property name for that, and here's my comment for that property. The second one is called the symmetric property. Kind of fits with symmetry and geometry. You know, you got it's symmetric around this line. Anyway, this one comes in handy when you're solving an equation. If you get to the very bottom of the equation and your answer looks like this, a lot of us are used to going ahead and just switching it to that. That's the use of the symmetric property. The transitive property also is kind of similar to something in geometry, the law of syllogism, but it says that if A is B and B is C, then you know that A is C. It's just connecting the end of this one with the beginning of that one, which means that these two are connected. It works the same way in all of these. And these are 3 names that you have to remember. 3 things that you probably know just naturally, but they have the names of reflexive, symmetric, and transitive. The distributive property, I'm not going to say a whole lot about this. We know it. We use it every day. A times B plus C is equal to AB plus AC. So what I'd like for you to do right now is to go ahead and hit pause on your video. See if you can answer these by matching them up. They should each have an answer. Again, hit pause on your video and take a couple minutes to match them up. Okay, we're back, and here are the answers to the matching. Please check down your sheet. You may want to hit pause again to just double check to make sure that you got them all right. That bottom one is a little bit covered up. The bottom 2 had answers of C and F. We've got the substitution property that we're going to talk about next. The substitution property is where you know that A is equal to B. That means that you can put B in place. This should be an A. You can put A in place of B in any equation or inequality. This is what we typically use when we're solving systems of equations. If you've got something that looks like this, this gives you the ability to say, okay, instead of that y right there, I'm going to put x plus 2 in that place because y is equal to x plus 2. So if you were solving a system of equations, when you put these 2 equations together, you would have 2x plus 3, but instead of the y, I'm going to put in x plus 2 is equal to 8. And that's how we justify solving systems of equations by substitution. The next 4 are the 4 that are probably easier just to show you than to go with the given formulas that go with them. They're all basically saying the same thing, and you've heard it over and over again when you're solving an equation or an inequality. What do we do to both sides? The whole point is if you have an equation or an inequality and you do the same thing to both sides, it doesn't change the value of the variable. So we've got the addition property of equality, we add the same thing to both sides. Of an inequality, we add the same thing to both sides. This is something like, x minus 2 is equal to 8. And we know that we can add a 2 to both sides, and we get x equals 10. They're that easy. The subtraction property of equality would be like x plus 2 is equal to 6. So we subtract a 2 from each side, and we get x equals 4. The multiplication property, if we had x over 2 is equal to 3, this means that we can multiply both sides by 2 to get the answer. And of course, the division one works the same way. The only thing that you need to be aware of is that when you're doing inequalities, if you multiply or divide by a negative, you have to remember to flip the inequality symbol. Let's take a minute to look at some of the problems that could be on your SOL test. This one right here says, choose the property that is illustrated below. And we've got 4 plus 7 plus 29. And we have 4 plus 29 plus 7. I said it that way, just forgetting about the parentheses to show that the order of the numbers is not the same. We're adding 3 numbers. We're adding 3 numbers on both sides. The order of the numbers is not the same, so that one would be the commutative property of addition because it was a change in order and it's addition, so it's the commutative property of addition. The next one says choose the property that's illustrated below, and we've got 3 times 4 times 7, 3 times 4 times 7. Numbers are in the same order, but the parentheses have moved, so that means it's associative. And since it's a multiplication problem, it's the associative property of multiplication. Next one, we've got choose the property. We've got 3 times, and then in parentheses, x minus 6, and then we get 3x minus 18. Of course, this is our favorite one, the distributive property. And we'll look at one more just to make sure we're good on this. Choose the property that's illustrated below. We've got 4 times 1 equals 4. Well, we got 4 for the answer. We started with 4. We multiplied by 1. That's an identity property of multiplication. Okay, I've got a couple minutes left. I did want to look at one more problem that was on an SOL test just a couple years ago. This is going to be an example of how you really want to pay attention to detail and not jump at the first answer that you see. We've got this problem over here where Jane is showing her work when she is solving an inequality. And we've got to go down and figure out where did Jane make a mistake. So, of course, the first step is going to be what you start with. That's given. That's no big deal right there. The next one, we've got the associative property of inequality. So how did Jane get from this step to this step? She distributed. She did 6 times 4 and then 6 times negative 3x. So we already know that step 2 is going to be the one that's wrong. I still want to go down and look at the other two. To get from step 2 to step 3, Jane added 20x to both sides. So that's the addition property of inequality. To get from step 3 to step 4, Jane subtracted 24 from each side. So again, that's the addition property of inequality. Now you could have thought that was a subtraction property of inequality and you'd still be right. That's why I said it's important to look at all of them. The distributive property is clearly the one that's wrong in step 2. In some cases, the answer could be 1 or 2 answers, but that's clearly the mistake. The last one, to get from step 4 to step 5, it looks like Jane divides by 2. You would think that it's the division property of inequality, but they chose to look at it as the multiplication property of inequality because they're multiplying by a half. That's the same thing as dividing by 2. Hope this helps. Good luck on your SOL test.